Hello there. Today we'll be doing a Leetcode daily challenge video, that is 78 subsets, and this is today's daily Leetcode challenge. And the problem goes by: given an integer array nums of unique elements, return all possible subsets, that is the power set. The solution set must not contain duplicate subsets. Return the solution in any order. And if we go by the statement, this is what we have to return as an output. So let's understand this properly on how we actually solve this problem. So I'll just get here and I'll show you. Let's just consider the same example that had been given. I'll just take a smaller example for this instance, and then I'll show you with a larger example. So if I tell you what are the subsets possible for this, so you would say an empty subset is a possible subset, 1 is a possible subset, 2 is a possible subset, and 1 2 is also a possible subset, right? These are the possible subsets that we can get. And what do we mean by subsets? We mean contiguous arrays, contiguous subarrays, sorry, of the same array. And this is what we mean by it. And also here we need to maintain the order as well. And you can see a empty subarray is also a part of it as given in the question. So now let's get to the bigger example. I'll show you with 1 2 3. So what do we get afterwards? So if I just add 3 here, what are the possible subsets that we can get? So here we can get an empty subsets, obviously. This is a must. 1. After that we'll get 2, right? After that we can get 3. After that we can get 1 2. Similarly 2 3 will get. After that we can get 1 2 3, and similarly these goes till 2 to the power 3. So basically if we have the length as 3, so here our length is 3, how many subsets we can form? That is equals to 2 to the power 3. That is 8 subsets are going to be formed, including the null subsets or the empty subsets. As you can see in the question, it was given here that we can get 8 subsets right here, and that is what we have to print. And how do we get this? We can simply use recursion to get these values from here. And how do we go about doing it? And let's just get to the recursion part. So we have the array as something like 1 2 and 3, right? This is what we are having here. What do I say at first? At first I can say either I can choose 1, or either I can choose 2, or either I can choose 3. So we will basically use a pick and non-pick condition, and we can do it. So at first we can say I will pick 1. So this is what I said. After that I'll say in my recursion, okay, I picked 1, now I'll also pick 2. This is what my recursion says, or I say rather. After that what I'll say is I'll also pick 3. Now you must be wondering, why did I only pick 1 2 and 3? Why cannot I not pick 1 and 3? So now we'll get to that part. I said that I'll pick 1, right? I'll pick 2. Now I can say instead of picking 2 afterward, I can also pick 3, right? This is one of my conditions. Similarly, now if I say I picked 1 and 3, right? Can I pick anything further? Obviously not, because the length is 3. I have already picked up 2. I cannot pick 2 again. So this is where we end. After that, what we can say here is I will not pick anything. This is what my condition says, right? So now we get here and I say that I can pick 2. I can pick 2. I said I will pick 1. I said I will pick 2 now. So if I pick 2, after that what can I do? I can either pick 3, right? Or I can say I will pick nothing. That is, I'll leave 2 alone, right? This is what I can say. Now what I can say is that I'll either pick 3 now. So after that, what I can say is I'll pick 3 only. After that I'll pick nothing, or after that my array ends, right? So that is what it is. So if I just reach the end of the array, I can say that yes, I have completed all the subsets. But has it been completed? If we carefully observe, we have not completed everything yet. We have actually missed some more. So that is, I've actually picked here 1. After that, I picked 2. After that, I picked 3, right? There could have been a possible instance where I did not pick 1 also. So this is that case I've not written. You could actually go by doing it and you'll understand. You did not. So this here becomes something like this. After that, this becomes something like this. And there will be more recursion calls. And I'm not drawing all. You could complete the tree and draw it. You'll understand it more clearly. And now I'll go to the solution part on how to actually code it, which is the interesting part. So if I just go to the code, this is the function call that is going on for generate, right? After that, I come here and I created a vector of answer, and here I said I either not pick it, and here I'm saying I'll pick it. And how does this condition work? So now let's get to the diagram again, and I'll show you how this actually works. So I'll erase this once more and draw it for some clarity. Just remove this part. Now let's get here. First of all, I said I'll pick 1, right? What is it? I said I'll pick 1. Either I choose or not choose. I could have written this above also, it doesn't matter, right? First of all, I'm saying I'll choose it. Okay, so I said I'll choose it, fine. After that, I can say I will not choose it, right? Now, otherwise, I can say I can choose another one, that is 2, right? After that, I can say I will choose another one, or I can say I will not choose one. So if I do not choose anything, if I do not choose 3, what do I get? 1, 2, and 3. And this is what condition. I can say I will choose, right? Or I'll not choose. So if I go here, sorry, this condition states that I've actually not chosen anything, just one, but one, right? So here I can choose one, or I can again choose nothing, right? So this is one of the conditions. So I've got right here one, and I can also get nothing from here. Now after I'm done doing that, I can say I will choose one. Now similarly for, I'll draw it for 2 and something like that, and I'll get it. The recursion tree, you'll get it. And this is how it goes. Now let's come to the code part. So this is what it does. If I want to choose it, what do I say? I'll just add it to my uh, sub vector which has been carried. Sub is just a temporary vector. That means if I come here again, I'll just show you. First I said I choose one, then I said I'll choose both the elements, and then I said I'll choose all the 3 elements, or I said I'll not choose any elements. So if at the end of the tree you look, every time when I'm at the end, my eye crosses this array bounds, right? Whenever this crosses the bound, what will I get? I'll just simply push it back into my final answer and just return back from there. And at the end of the day, I'll just return the answer. What is it? It is my combination or the power set that I had generated from this recursion. And if I just run this, it will run perfectly fine. And I've already submitted it, this code, and I'll just show it to you. So I've already submitted this. Okay, I'm not submitting this again. So as you can see, I've already submitted. Yeah, and this is it for this video. And if you did like it, please like this and do subscribe if you understood the solution. Thank you.